Welcome to this deep dive. We're continuing our look at the online encyclopedia of integer sequences, really for you number theory students out there.
A fantastic resource.
Absolutely. And today, we're zoning in on one sequence that, well, it keeps showing up. OEIS, A000226.
Yes, A000226. It really highlights the power of the OEIS, this sort of central index for number patterns.
It really does.
Yeah.
So what is A000226 formally?
Okay, formally, it's counting the number of n-node unlabeled connected graphs, specifically those that have exactly one cycle.
Okay.
And that cycle must be length 3, so single triangle, essentially.
A triangle, got it. And it used to be called M2668 and N1066.
That's right, older designations.
So picture M points connected all in one piece, but with just one triangle structure inside.
Precisely. And the sequence starts 1, 1, 3, 7, 18, 44.
Wow, it grows fast.
It does. The list goes on 117, 299, 793, quite rapidly.
And the offset is 3, 3, so it starts at N3.
Yes, A3 is 1, which makes sense, you know?
Yeah, the smallest graph you can have with a triangle needs 3 nodes.
Right.
But what's really fascinating, and you hinted at this, is how these sequences appear elsewhere.
That's the magic of it. So Christian G. Bauer found that A000226 also counts something seemingly different.
Wow.
It counts the number of rooted trees on n+1 nodes,
Okay, and plus 1 nodes.
where the specific root node has degree exactly 3.
Huh. So a tree structure, like a family tree,
Right.
with n+1 points.
Right.
And the very top point, the root, connects to exactly 3 others.
Yes. It's not immediately obvious why counting those graphs with a triangle gives the same number as counting these specific trees.
It really isn't. It makes you think there must be some, like, structural equivalence.
That's often the case. It suggests a deeper combinatorial link, maybe a bijection, a one-to-one mapping between the two sets of objects.
Interesting. Are there other interpretations?
Oh, yes. Michael Somos noted it's the third column of another sequence, A033185,
Okay.
and Washington Baumfim added a couple more perspectives. He showed it counts the number of forests, collections of trees specifically, forests of 3 rooted trees that have n nodes in total.
3 rooted trees adding up to n nodes.
Okay, and perhaps less surprisingly, he also phrased it as the number of unicyclic graphs with just one cycle, where that cycle is length 3 and there are n nodes total.
Right, which brings us kind of back to the start, but with slightly different wording.
Exactly. It just reinforces that core idea.
It's just amazing. One sequence tying together graphs with triangles, specific rooted trees, forests.
It really shows the interconnectedness, doesn't it? The hidden unity.
And this sequence isn't some brand new discovery, right? It has an history.
No, it's been known for a while. John Riordan, the combinatorialist,
Oh, right.
he included it back in his 1958 book, An Introduction to Combinatorial Analysis.
Wow, 58.
And then, naturally, it was picked up by Niels Sloan for his original Handbook of Integer Sequences in 73.
The classic.
And later in the bigger encyclopedia with Simon Plouffe in 95. So it's a well-established sequence.
Its presence in those major works definitely signals its importance.
Absolutely.
Now, for listeners who want to dig deeper, the OEIS page itself is a goldmine, isn't it?
It really is. There are links to extensive tables, like Alois P. Heinz's table going up to N1000.
1,000 terms.
Yeah. And there's an interesting article by Sergei Abramovich linking it to partitions and spreadsheet modeling.
Spreadsheets. Unexpected.
And Washington Baumfim, he provides some nice illustrations for the first few terms, which can help visualize things.
Visuals are always good. Any other key resources linked?
Well, there's F. Resky's book, Combinatorial Generation, which has a relevant equation, 4.27.
Okay.
And Eric Weisstein's World of Mathematics has an entry on rooted trees. Plus, the OEIS page links to other related sequences, especially about rooted trees.
Right, you can really follow the breadcrumbs. Let's talk about the generating function. That's often where the real structure is revealed.
Yes, exactly. The generating function gx for A000226 is given by, well, it involves the generating function for rooted trees. Let's call it R at x.
Which is A000081.
That's the one. So gx is Rx3 plus 3xr past 2 plus 2r by 3, 6.
Okay, that looks structured. The Rx cubed, the Rx2, Rx3, that must relate to how you build these graphs.
Precisely. The form often reflects the combinatorial construction. It suggests ways of combining rooted tree structures, possibly one big one, or combinations involving smaller ones derived from powers of x to form these graphs with a single triangle. It's related to polyenumeration theorem principles.
Fascinating. And Bomfim had another formula.
Yes, an alternative sum formula. It involves binomial coefficients and the terms of A000081, the rooted tree counts. He notes it's related to that equation, 4.27 in Ruskey's book.
Again, reinforcing that deep connection to rooted trees.
It's a recurring theme.
We mentioned the sequence grows fast. Is there an asymptotic formula for large N?
There is. Vaclav Kotosevac provided one. It says AN behaves roughly like, well, it's a constant involving terms from A18777Z and A339986 times A051491 raised to the power n, all divided by 2n32.
Okay, so the dominant term is that A051491N part, exponential growth.
Exactly. That A051491 is approximately 2.955. It's the key growth constant for rooted trees as well. The N32 in the denominator is also typical for tree-like structures.
So the asymptotics also point back to trees. It all ties together.
It really does.
And for people who want to compute terms themselves.
The OEIS entry is helpful there too. There's Maple code using the generating function.
Right.
There's Mathematica code calculating terms via the rooted tree function, Rx.
Handy.
And Washington Bomfim also provided ParaDP code, giving another computational approach.
Lots of options for exploring.
Yeah.
And the cross-references. You mentioned A033185 earlier.
Yes, there are quite a few links. A033185, A217781, the rooted tree sequence, A000081 itself, A001429, and there are specific relationships noted, like for any three are AN equals terms in A217781, A058879, and A033185.
It's like a dense web of connections within the OEIS.
That's exactly what it is. And you can also see its neighbors, A000225 just before it, A000227 just after. Gives you context.
What about the keywords?
Meaning non-negative integer sequence, which is standard for counting, and nice.
Nice. What does that usually mean in OEIS terms?
It's a bit subjective, but generally means the sequence is, well, mathematically appealing. It arises naturally, has interesting properties, good combinatorial interpretations, like this one.
Fair enough. And the history on the page itself.
It credits N.J. Sloan as the original author, with Lededa Jovovich adding more terms later. It's marked as approved, so it's a validated entry.
And it shows the last modified date, reminding us the OEIS is actively maintained.
Indeed, a living database.
So wrapping up our look at A000226, we started with connected graphs having just one triangle, but we quickly found it also counts specific rooted trees and even forests of rooted trees.
That's the key takeaway. This sequence pops up in multiple combinatorial settings, revealing these sometimes surprising mathematical connections. It's a perfect example of why the OEIS is so valuable, especially for you students exploring number theory and combinatorics.
Absolutely. It's a map to hidden pathways in the world of numbers. So maybe a final thought for you listeners, particularly the students. Given that A000226 counts graphs and trees and forests, how might thinking about these different structures, these different combinatorial viewpoints, give you new insights into why the generating function looks the way it does, or why the asymptotic growth behaves like N32 times an exponential?
That's a great question. How do the combinatorial decompositions relate to the analytic formulas?
Exactly. Something to explore using the OEIS links and formulas we talked about. Keep digging. Thanks for joining us on this deep dive.
My pleasure.